everyone. So this is the continuation of the derivative of transcendental functions. Now we go to the derivative of hyperbolic and inverse hyperbolic functions. Okay, so these are our objectives: to differentiate functions involving hyperbolic functions, to solve problems involving differentiation, and apply the theorems to simplify the functions. Now we have here the definition of what a hyperbolic function is. So hyperbolic functions are defined in terms of exponential function. So for hyperbolic sine, this is the definition. For hyperbolic cosine, hyperbolic tangent, okay, cotangent, secant, and hyperbolic cosecant in terms of e to the x. Now, but we just focus on how we find the derivative of functions and how we simplify the resulting derivative by using the hyperbolic identities. So again, I discussed this already with you, but let me just go over this one again. So we start first with the identities or hyperbolic identities. So we have here the squared identities, and it's similar to the identities or the trigonometric identities. They just differ in signs, right? So we have hyperbolic cosine square minus hyperbolic sine square x equals 1. 1 minus hyperbolic tangent square is hyperbolic secant square, and hyperbolic cotangent square x minus 1 is hyperbolic cosecant square x. Then we have here the double angle formulas. And then we have the sum and difference of two different angles. Now, if you're going to, you have to go back to the copy that I gave you for other, because this is incomplete. You can, okay, you can go, go to that copy for the other identities. Then we have here the different differentiation formulas. The first is the derivative of hyperbolic function. Now look, as I mentioned, for trigonometric and hyperbolic, they are the same. They just differ in signs here. The first three are positive, the last three are negative. Alright, now we go to the examples. Find the derivative of each of the following functions and simplify the result. So we start first with y is hyperbolic sine x multiplied by hyperbolic cosine x. Cosine 2x. So we apply here the product rule. We have, applying the product rule, this is u and this is v. So we use, what's the product rule? It's a derivative of u times v is u dv plus v du. So for y prime here, we copy, this is your u and this is v. So we copy hyperbolic sine x, derivative of hyperbolic cosine is hyperbolic sine 2x times 2. And then plus, we copy hyperbolic cosine of 2x times the derivative of hyperbolic sine, which is hyperbolic cosine of x times the derivative of x, which is 1. So if we simplify, we'll get y prime is 2 hyperbolic sine x times hyperbolic sine of 2x plus hyperbolic cosine 2x hyperbolic cosine x. Now, by using the hyperbolic identities, this one here, we say that hyperbolic sine 2x is 2 hyperbolic sine hyperbolic cosine. So we can change this hyperbolic sine 2x by using this one into 2 hyperbolic sine x hyperbolic cosine x. Okay, let's change. the color. So again, this is equal to 2 hyperbolic sine x hyperbolic cosine x. Okay, so because here the angle here is 2x, and we make it similar to this one using this identity that hyperbolic sine 2x is 2 hyperbolic sine x hyperbolic cosine 2x, and that we have here hyperbolic cosine 2x is hyperbolic cosine square x plus hyperbolic sine square x, and we need to multiply this by hyperbolic cosine x. So this is the value of hyperbolic cosine 2x. Okay, so if we simplify further, this gives you, if we multiply this y prime now is 2 times 2 is 4 hyperbolic sine square of x hyperbolic cosine x, plus we need to distribute hyperbolic cosine, this one, we distribute this here, and so we get hyperbolic cosine cube of x plus hyperbolic sine square x hyperbolic cosine x. And then we have similar terms here, hyperbolic sine square, we have, because this is hyperbolic sine square hyperbolic cosine, so we have 5 hyperbolic sine square x hyperbolic cosine x, right? 4, okay, sine square cosine plus hyperbolic cosine square x, and then we can factor out here a common factor, which is, let's say common, this is hyperbolic cosine is common, you could factor it out. Okay, let's factor out hyperbolic cosine x. So we'll have here 5 hyperbolic sine square x plus hyperbolic cosine x. And then if we, because how many variables do we have? I mean, how many functions do we have? We have cosine, we have sine present. So we can also express this in terms of one function only. So how will you change that into one function only? We could use now this one. Cosine square x is minus sine square x equals 1. So we could solve for the value of sine square x. So what is sine square x here? From here, hyperbolic sine square x is 1 minus hyperbolic cosine square x. And then this is 1 minus hyperbolic cosine square x. So therefore, you'll have here hyperbolic cosine x times 5, and hyperbolic sine is 1 minus hyperbolic cosine square x plus hyperbolic cosine of x. So if you simplify further, this gives you hyperbolic cosine x, that's hyperbolic cosine x times, distribute 5. So 5 minus 5 hyperbolic cosine square x plus hyperbolic cosine x. And so what happened? We have 5 minus 5 hyperbolic cosine square x. Okay, hold on. There is something wrong with this one. Sorry. Because this should be, when we transpose, this should be positive. This must be positive. Kasi we transpose sine on the right side becomes positive, and then you'll have, oh, this should be, there's something wrong with this. Okay, sine squared, this should be, sorry, hyperbolic cosine square x minus 1. So therefore, we did something wrong with this one. This should be hyperbolic cosine square x minus 1. And so we need to change this. Okay, so therefore we already have changed this into hyperbolic cosine square x minus 1. Now if we distribute, we'll have 5 cosine square x minus 5, then plus, oh, this should be, hold on, there is something wrong with this. This should be square. So from here, 5 hyperbolic cosine plus cosine square, right? So we'll have 5 hyperbolic cosine minus 5 plus hyperbolic cosine square x. Okay, so we'll have now, the final answer is hyperbolic cosine x times 5 plus 1 is 6 minus 5. So this is our final answer. Okay, now the next is, how do we find the derivative of this one? So what formula will you use first? ln of u. So the derivative of ln of u is 1 over u, and your u is hyperbolic sine x squared, times the derivative of hyperbolic sine, which is hyperbolic cosine of x squared times 2x. So therefore, if we simplify, hyperbolic cosine over hyperbolic sine is hyperbolic cotangent of x squared times 2x. Right? For this one, again we use here ln of u. So 1 over u hyperbolic cotangent square of x times what? Derivative ng hyperbolic cotangent square. But for the derivative of hyperbolic cotangent square x, if this is your, what's the derivative of hyperbolic cotangent square? First, you know that there is no, because you can write hyperbolic cotangent square as what? Hyperbolic cotangent x squared. So that you can find the derivative of hyperbolic cotangent of x squared, which is what? U to the n. So we have n hyperbolic cotangent x to the 2 minus 1. And the derivative of hyperbolic cotangent is negative hyperbolic cosecant square x. So if we simplify, this now gives us, so we can use here expressing hyperbolic cotangent in terms of, or cosecant in terms of cotangent. But we can also use we can also use the definition or the value of hyperbolic cotangent, which is hyperbolic sine over hyperbolic cosine. So this is now 2, the numerator is 2, hyperbolic cotangent is hyperbolic cosine over hyperbolic sine. And then in the denominator, you also have, hold on, hyperbolic cotangent. Now, we multiply by negative because of this one. And then, hyperbolic cosecant square is 1 over hyperbolic sine square. Because from the reciprocal identity, sine hyperbolic sine is 1 over hyperbolic cosecant, and vice versa. So that hyperbolic cosecant is 1 over hyperbolic sine. Then we divide it by hyperbolic cotangent, which is in terms of sine and cosine, it's hyperbolic cosine square x over hyperbolic sine square x. And then we simplify this by multiplying the numerator by the reciprocal of the denominator. So what's our numerator now? Negative 2 hyperbolic cosine x over hyperbolic sine cube of x. And the reciprocal of the denominator is over hyperbolic cosine square x. So this cancels out with this one and this one too. So what's left in the numerator? We now have negative 2. Cosine is out already, so you have also sine. Hold on. Negative cosine, yeah, 1 of the sine is left, minus 2, hold on, it's minus 2, and then cosine is out, hyperbolic sine is left, right? Cosine is out, one of the, okay, so in the denominator, tanggal din pala yung sine. Yeah, there's no, this is also removed, hold on, back, because this one we cancel out sine square and cosine, so only negative 2 is left in the numerator. In the denominator we have 1 hyperbolic sine, right? 3 minus 2, and 1 hyperbolic cosine. Alright, then we may just actually we can simplify further by writing or multiplying both the numerator and the denominator by 2 over 2. Our objective is to make this to have 2 here, because if you have 2 here, this becomes a double angle 1, because we have this formula here that hyperbolic sine 2x is 2 sine x cosine x. So if we multiply this, the denominator by 2, we multiply also the numerator by 2, so that this changes into y prime is negative 4, and then 2 hyperbolic sine cosine is hyperbolic sine of 2x. So it could be this one, or pwede rin na y is negative 4 hyperbolic cosecant of 2x. Right, so we use identities. We use the reciprocal identities. Now we go to the next one. For the next one, we have y is ln of hyperbolic cotangent square. So y prime is equal to what? This is u. So 1 over hyperbolic cotangent square x. Again, hyperbolic cotangent square x is the same as what? Hyperbolic cotangent of x square. So the derivative is, we use here u to the n. So we have n hyperbolic cotangent x to the 2 minus 1. And the derivative of hyperbolic cotangent is negative hyperbolic, it's positive. Positive hyperbolic cosecant square x times 1. So again, we can simplify this into, we can use again, or we may change this again into sine and cosine. So we have, in the numerator, we have 2 hyperbolic cotangent is hyperbolic cosine of x over hyperbolic sine x. Then we divide it by hyperbolic cotangent square, which is again, we can first, okay, hold on. We can first cancel pala. Because we have here this one, we can cancel it with one of these. So if we write down the simplified form, we have 2 hyperbolic cosecant square x over hyperbolic cotangent x. And then we have 2 times hyperbolic cosecant is 1 over hyperbolic sine square x. We divide it by hyperbolic cosine x over hyperbolic sine x. And so this gives us 2 over hyperbolic sine square hyperbolic sine square x times the reciprocal of the denominator, which is hyperbolic sine x over hyperbolic cosine x. So then this, one of these cancels with this one. So if you simplify, we have 2 over hyperbolic sine x hyperbolic cosine x. So again, this is similar to, hold on, we repeat this one. Na-repeat lang siya. What happened? No, okay, let's continue because this is different. I think this is a different solution because what we did here, did you get the same answer? Hold on, cotangent square. What did we do here? There's something wrong with this one kasi dapat ito positive. So we get a negative answer. That's correct. Ln of hyperbolic cotangent, it's exactly the same. We have the same solution to, yeah, cosecant square. But this must be, yeah, it's negative. The first 3 are positive. So dito, yeah, we're done with this one. We get the same answer. Actually, negative dapat ito. Hold on. Let's just erase this one. We did this in the previous number. Okay, so okay, let's just do here. Hold on. Let's just do here number 3. Kasi we did numbers 2, 4, and 3 here. Let's do number 3 on this. So let's do here number 3. So first 3, we are given y is hyperbolic secant square x. So how do we find the derivative of this one? So we can write this as hyperbolic secant x square. Kasi there is no formula for hyperbolic secant square x. So we can write the derivative as what? We use here u to the n. So we get y prime equals n, which is 2 hyperbolic secant x to the 2 minus 1. And the derivative of hyperbolic secant is hyperbolic secant, hyperbolic cosecant x times 1. Now, remember the first three are positive for hyperbolic functions. The last three are negative. So, this must be negative. Okay, so we get here y prime is negative 2 hyperbolic secant square x times hyperbolic cosecant x. For hyperbolic secant, sorry. This should be hyperbolic secant tangent. Dapat tangent ito, sorry. Secant tangent. So this must be hyperbolic tangent. So this is the final answer. Okay. Now these are some exercises for you to do. But there is also a solution for this exercise for the first one. Okay. Now the next is how we find the derivative of inverse hyperbolic functions. Then this is the definition. So inverse hyperbolic function is defined in terms of logarithmic function. Okay. These are the definitions. And then here is your differentiation formula. So again, as I mentioned, we write the derivative side by side so that you see the differences between the two. So we're now on the derivative of inverse hyperbolic. Okay, so alright, so what's the difference with inverse trigonometric? Here you have for inverse trigonometric, 1 minus u square. Here you have 1 plus. Then u square minus 1 for inverse hyperbolic cosine. Remember, for inverse hyperbolic tangent and cotangent, they are exactly the same. Then this is for inverse secant, inverse hyperbolic secant, and inverse hyperbolic cosecant. Okay, let's do the first example. We have here this one. We are asked to find the derivative of x inverse hyperbolic sine x minus this one. So what formula are we going to use here? What formula do we use here to find the derivative? For the first one, so you find the derivative of this and this one. For the first, we use the derivative of product. So what's the derivative of product? So this is u and this is v. So we copy u, which is x. And then what's the derivative of inverse hyperbolic sine? So that's du dx. The u here is this one, and the derivative of x is 1. So it's 1 over the square root of what? Because for the inverse hyperbolic sine, it's du dx over 1 plus u square. So over 1 plus x square. Then plus inverse hyperbolic sine x times the derivative of x, which is 1. So again, this is u, this is dv, then you have your v, and this is du. Then minus the derivative of the square root of x square. We get the derivative of this one. And that will give you derivative of the square root of u. U here is 1 plus x square. So the derivative of 1 plus x square is 2x over 2 square root of 1 plus x square. 1 plus x square. So this will cancel with this one. And you have here plus x times the 1 over the square root of 1 plus x squared. And it's the same as this one. So these two are similar but opposite in signs. So that leaves you 0. So when you simplify, g prime of x is simply inverse hyperbolic sine of x. So that's the derivative. Okay, let's do number 2. So for number 2, we are given here y is ln of this one. Now, we can first simplify. Write this as ln of x squared minus 1 to the 1/2 plus x. Okay, and then we can bring down 1/2 because it's easier to differentiate if we simplify first using the laws of logarithm. So y prime now is, we copy 1/2, it's a constant. Then the derivative of ln of x squared minus 1 is 1 over x squared minus 1 times 2x. Plus for this one, we use derivative of product. So we copy x, then the derivative of inverse hyperbolic tangent is 1 over 1 minus u squared. And the u here is x. So minus x squared. Plus inverse hyperbolic tangent x times the derivative of x, which is 1. So if we simplify, 2 cancels out. You have here x over x squared minus 1 plus x over 1 minus x squared plus inverse hyperbolic tangent of x. But we can write this as what? The negative of x squared minus 1. Right? So we'll now have y prime is x over x squared minus 1. Then this becomes minus x over x squared minus 1 plus inverse hyperbolic tangent of x. So again, these two cancels out. They're the same. So the result is inverse hyperbolic tangent x. Okay, then let's go to the next one. Now the next is, you have here inverse hyperbolic cotangent of this is u. So what is g prime of x? What's the derivative of inverse hyperbolic cotangent, sorry. G prime of x. So in the numerator, we write the derivative of hyperbolic cotangent. And what's the derivative of hyperbolic cotangent? But remember, the first three are positive: sine, cosine, tangent. Then, what's the derivative of hyperbolic cotangent? Negative hyperbolic cosecant square of the square root of 4x times the derivative of the square root of 4x, which is 4 over 2 is square root of 4x. Then over what? So this is your du. This is the derivative of u over what? Over 1 minus u square. So 1 minus, what is your u? Hyperbolic cotangent square of the square root of 4x. Like du dx over 1 minus hyperbolic cotangent of the square root of 4x. 1 minus u square. Again, let's write the formula. Derivative of hyperbolic cotangent u is du dx over 1 minus u square. Okay, now, so what we did is that we differentiate hyperbolic cotangent, which is this one. Then we simplify. So if we simplify, what happened? This cancels out. So we'll have negative cosecant square of the square root of 4x times, what happened? Times what? 2 over, but the square root of 4x is actually 2. So we can cancel this one now. Sorry. Because here we have, the denominator here is, you have here 4, right? So the square root of 4 is 2 times 2. It cancels with 4. So we only have, what's left in the numerator is just simply negative hyperbolic cosecant square of the square root of 4x times what? Ay, what happened? Times 1 over the square root of x. Right? Square root of x. Because we cancel the 2. And then in the denominator, we have 1 minus hyperbolic cotangent square of the square root of 4x. So by using the identity, we have cotangent. Our identity is that, let's write it here. We have hyperbolic cotangent square x minus 1 is equal to hyperbolic cosecant square x. Di ba kita? Let's rewrite it. We use here the identity that hyperbolic cotangent square x minus 1 is hyperbolic cosecant square x. So if we solve for, if we transpose cosecant on the left side, if we transpose, we want 1 minus cotangent. So we can multiply both sides by negative 1. So if we multiply both sides by negative 1, this becomes negative, we multiply this by negative 1 also. So the result is 1 minus hyperbolic cotangent square x is negative hyperbolic cosecant square x. Okay? So, it means that this is equal to negative hyperbolic cosecant square of the square root of 4x times 1 over the square root of x over negative hyperbolic cosecant square of the square root of 4x. So therefore, this simply cancels out. And so we get as a result. If we simplify, we get what? It becomes positive, and it now is equal to simply 1 over the square root of x. So that's, square root of, this should be 4x. Sorry. Dapat ito 4x. Lahat dapat 4x. Naging x dito. This should be 4x. So the final answer should be 4x also. Okay, so we can rationalize. Okay, so if you rationalize square root of 4x, it becomes square root of 4x over 4x. That's your g prime of x. Okay, so hold on. We did something wrong. 4x, naalis naman natin yung 4x pala. So we have to remove, kasi this already out. So this becomes x. Dapat x nga siya. Right. X siya. And then this should also be x. And so this becomes, dapat na to. 1 over the square root of x, or g prime of x is square root of x over x. Right? So then the next one is this one. So what is your y prime? What's the formula for inverse hyperbolic cosecant? So this is u. What's the derivative of cosecant? Inverse hyperbolic cosecant of u. That's equal to 1 or du dx over u times the square root of 1 plus u square. And it should be negative 1 or negative du dx over u square root of 1 plus u square. Alright, so what is our y prime? Okay, hold on. We have, for y prime, is a derivative of u. And this is, your u is x squared over 2. So you could write it as 1/2 times x squared. So 1/2 times the derivative of x squared, which is 2x. Then we divide it by u, which is x squared over 2 times the square root of 1 plus u squared. So x to the 4th over 4. Okay, so if we simplify it, it should be negative. So we can cancel the 2. In the numerator, it's negative x. Now, in the denominator, x squared over 2, you could get the LCD here, which is 4. So you have 4 plus x to the 4th. And then simplify the denominator further. So we'll have x squared over 2. And this can be the square root of x, the square root of 4 plus x to the 4th over the square root of 4 is 2. So then we write this as minus x over x squared square root of 4 plus x to the 4th over 4. And then if you simplify further, we multiply negative x by the reciprocal of the denominator. So we have 4 over x squared square root of 4 plus x to the 4th. So one of the x cancels out. So now we get y prime is negative 4 over x square root of 4 plus x to the 4th. This is our final answer. That's your y prime. Okay, so that ends our lesson on hyperbolic and inverse hyperbolic function. Bye-bye.